Next question, question number 24. A particle of mass m and initial velocity v collides with a particle b of mass m by 2 which is at rest. The collision is head-on and elastic. The ratio of the de Broglie wavelengths lambda a to lambda b after the collision is lambda a by lambda b is equal to 1 by 3, lambda a by lambda b is equal to 2, 2 by 3 and half. We will see how to do the sum. Let's say this is a body of mass m1, we can even take it to be a particle. Let's say a body of mass m2, this is moving with a velocity, let's say u1, let's say this is u2 initially. I am discussing general case, then come to the problem. Okay, initially the velocity of the first body, mass m1, velocity u1. Second body, mass m2, it's also moving with a velocity u2. I am going to consider one-dimensional collision which is elastic. Okay. Of course, the theory and the derivations we will skip here. I'll give you the final expressions for the velocity of this body after collision as well as the velocity of this body after the collision. From the derivation we get v1, that means velocity of this body after the collision is m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. Derivation we will not be doing here, we are only doing problems. If you want, you can put vector symbol, but we are not going to consider the vector ideas here. So without this we can proceed. Then what about the velocity of this body after collision? m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. Okay, yeah. Now how will you use this formula for this problem? For this problem, m1 is equal to m, m2 is equal to m by 2, and of course u1 is initial velocity of this, which is v. If need be there, we will substitute that. u2 is 0 because it's given second body is at rest. Substitute all these things and see what happens. Okay, so first we will see how to find v1. So I write here, I think I can remove this diagram. v1 is equal to m1 minus m2, m minus m by 2, so m by 2, m1 plus m2, m plus m by 2, so 3m by 2. u1 is v, u2 is 0, so you forget this. So you get m by 2 into 2 by 3m into v. 2 and 2 will go, m and m will go, you are getting v by 3. So what is that you are getting? v1 is v by 3. Keep it, you are going to use it. Come to this v2. What is v2? Is equal to, u2 will be 0, u2 is 0. Because u2 is 0, this will go off. 2m1, 2m1 is m, by m1 plus m2, 3m by 2, u1 is v again. So 2m v by 3m, this 2 will go to the numerator into 2. M and m will cancel, you are getting 4 by 3 into v. Now you know the de Broglie wavelength formula. In general, lambda is h by p. De Broglie wavelength given by h by p, h Planck's constant, p is the linear momentum of the body, of the particle. H being constant, we can say de Broglie wavelength is inversely proportional to the linear momentum, because h is constant. So we want lambda a by lambda b is equal to, here a will correspond to the first body, b will correspond to the second body. Lambda a means, you can write this as lambda a by lambda b, you can write this as m2 v2 by m1 v1, because inversely proportional to momentum, momentum formula mv. So m2 m by 2, v2 4v by 3 by m1 is m v by 3. Is it okay? Simply substituting. Okay. Yeah. Now simplify further. Lambda a by lambda b is equal to 4 mv by 6. This is v here. 4 mv by 6 into, this 3 will go to the numerator, denominator is v. Okay, mv and mv will cancel, this 3 and 4 you can cancel here with 6, 4 by 2 is 2. So correct answer is option 2. Understood it? Thank you.